We are starting module 3, so that's where I just put that slide deck that I posted to you. Instead of in module 2, it's in module. We are starting module 3, which is relations and functions. We're not going to do lots and lots today, but we are going to make sure we know some vocabulary words like relations and domain and range and independent variable and dependent variable. So we're going to do that by looking at the McGraw-Hill textbook together very quickly. It's up to you. You can just watch me look through it, or you're welcome to join me in going through it. And then that we're going to have an Alex assignment of 6 problems, and I'm going to go through each type of problem that's in that assignment. The rest of the time will be yours to get that assignment done. Okay, anybody have questions? Or I see I see a couple people have responded while I've been all distracted with my own shortcomings. All kinds of people. Cloudy, cloudy. I'm sunny and cloudy. Can't tell. Too bright. Well, that's good. At least I think that might be good. Too bright is a... So what I've been saying is it's cloudy, but the sun is determined to shine through. That's my state of being at the moment. I think the sun's doing a little bit better and a little bit better for my day. Uh-oh. Glass is kind of scuffed is not fun at all. All right. Let's switch over to our textbook. Remember, our textbook is the McGraw-Hill textbook that we can get to through Clever. And I'm trying to get there real quick. So if you choose to log in, or if at some later point, just a reminder, we're in module 3 now. This is the first day we've started that, and so we're on lesson 1 of module 3. I'm just going to go ahead and click this launch presentation. Hi, Marco. Thanks for turning your camera on, man. And we're not using everything by a long shot, but I can then open the tray down here in the lower right corner, and very quickly the vocab that I was talking about. This is just, I'm not going to look at the definitions here, but at least it's the list: relation, domain and range, independent and dependent variable. Those are the vocab words we're trying to make sure we have a basic understanding of. And now I'm going to motor right on over here to learn relations. Okay, so this is an example. The short definition of a relation is that it's a set of ordered pairs, but this is an example just trying to help us relate it to real life. Those ordered pairs are going to be numbers that somehow relate to one another. And so in this problem, they're talking about relating what day it is to how many minutes you've driven or someone's driven. So these numbers up here, 1 through 7, are representing the days, and then 30, 45, 20, 40, those are representing how many minutes we've driven. And so that's those two sets of numbers create a relation. The way that happens is day 1, comma 30 makes an ordered pair. And so if we link day 2 to 45 and so on, we have a relation. The domain is this first set of numbers, and the range is the second set. So let's look at an actual set of ordered pairs. So you see right down here, this is not the numbers that were up here, so don't try and link those together. This is just a different random set of ordered pairs. And when I click on relation down here, it shows me that, well, this whole thing is a relation. I just want to point out that this curly bracket here and this one over here, that's what we call set notation. And so those brackets are telling us here's a set of something. In this case, it's a set of ordered pairs. The first ordered pair is 3, 5. The second ordered pair is -4, 1, and the third ordered pair is 0, -2. Those three ordered pairs are forming a relation. Then the domain, we said it's the first numbers. So when they're in ordered pair form, that means we're looking at the first number in each ordered pair. And I bet most of us have played with ordered pairs enough to know that any ordered pair is representing an x value, comma, a y value. So if the first number is always your x value, then really the domain is all of your x values. Okay. Then the range, being the second number in each ordered pair, that would be all of your y values. Any questions there? Well, there is one more page to this particular resource, and it shows us all the ways that we can represent a relation. We won't go really far into it at the moment, but there are 4 ways. This paragraph right here says a relation can be represented as a graph, a table, a mapping, or an equation. So you see they have the same ordered pairs right here that we were just looking at on the previous page, but they're showing us 4 different ways to represent these ordered pairs. On a graph, they really did graph 3, 5. They went over 3 and up 5. Don't worry, we'll do some review of graph and ordered pairs for anybody that needs it, but that's the 3 points on a graph instead of written out in ordered pair form. Hey there, Devon. Thanks for turning your camera on. Good to see you, sir. And then we've got this equation represents the same ordered pairs when it says, well, here's an equation, but we're only going to use it for these x values. But if I put this x value of 3 in there, this is just saying take your x value and make it 2 bigger. Well, 3 plus 2, that's 5. So this ordered pair came from doing this rule. This, if you want to know what y is, take your x and make it 2 bigger. Each one of these is that way. Take this x of 0 and make it 2 bigger, and you got a 2. Then this is a table of values, 3, 5, -4, -2. You see those are just the ordered pairs that were already up there. But it's kind of nice because now I can really easily see all the x values and I can really easily see all the y values. And then this is that mapping thing. It's just taking all the domain numbers, which would be our x's, putting them in a column, and then taking all the range numbers, putting those in a column, and drawing arrows from each number in the domain to what number they go to in the range. This one, all the arrows just go straight across, but if you happen to look at this one up here, the 2 goes straight across to 4, -6 goes straight across to 9, but the 1 also happens to map to the number 9, so it looks a little different. Okay. All right, so 4 ways to represent a relation. We're only going to look really at this equation situation and this table situation today. So don't get worked up, just giving you an overview at the moment. Example 1, I'm going to try and do it pretty quick because I'm trying to give you as much time as I can. You see right here, they've given us 4 ordered pairs. This is a set of 4 ordered pairs that are a relation. And so the one way we can represent that is as a table. And you see this actually had the y values over here to the left of the table. I've already put them in there. Actually, both values were, now that I think about it. I believe I had to drag both values to the appropriate place. So like, wait a minute. Oh, yes. 2, 0 was already in the table for me, 2, 0. But then I had to drag 0, 4. So the x value 0 and the y value 4 is now in that table. And then the x value 3 and the y value -5 in the table, so on. Here, we've graphed them, the same 4 ordered pairs, create these 4 points on a graph. And then our mapping for this particular relation looks like that. Okay. Down here in part B, they're showing us how I can write the domain as a set of all of the x values. Okay. They've actually taken the time to put them in order, numerical order from smallest to biggest. That's a good thing to do, but it doesn't, in our Alex assignment today, if you don't put them in numerical order, it's not going to count it wrong. Okay. Same thing with the range. They went ahead and put them in numerical order, but that's not necessarily a requirement on today's Alex assignment. Any questions, guys? Okay, one last part that I want to look at. It says analyzing graphs, but that's not really what we're going to do with it right now. We're just going to use it to make sure we understand or have an introduction to dependent and independent variables. So this third paragraph right here says the values in the domain correspond to the independent variable of the relation. Our independent variable is something that's subject to a choice, is how this textbook is saying it, but it's just saying it doesn't depend on anything else. You can just pick a value because it's an independent variable. It's not dependent on something else. And that normally goes with our x. So that's why it says usually x right here. So whatever is on this x-axis is normally your independent variable. So in this case, our independent variable would be days. But then your dependent variable, which is usually y, it's dependent on your x variable. So how much time we've driven is dependent on how many days we're talking about. At day 0, we hadn't driven any, but by day 10, we've driven a whole bunch over here. Okay, you see the driving time's gone up and up and up to make it more and more and more driving time. So how much time I've driven very much depends on how many days have passed, but it doesn't work the other way around. I can't say, well, how many days have passed totally is determined by how much I've driven. I might drive none for 2 weeks, but that doesn't change what day I'm making it to. So days don't depend on driving time, but it does work the other way. All right, so independent variable, that's x. Dependent variable, remember we plug x in to find out what y is. So dependent variable is normally our y. That means when I look at this example for a half second, and it asks me to identify my independent and dependent variable, well, time is independent. It's my x-axis, so it's my independent, and then how many text messages have been sent? Well, that does depend on how much time's gone by. So this is my dependent variable. All right. Any questions? We're going to switch over and look at 3 examples real quick here. And then it'll be time for Mr. Reed to stop talking to you and you to be able to just make sure you practice what we're talking about. So here's our first example. And even before you learned about relations, I am guessing you have seen plenty of these, but just a quick reminder for anybody that could use one. Right here is the rule to help us figure out what the y value is. If you want to know y, take the number 23 and subtract 3 times the x value. So I'm just going to write that rule right over here next to my table. Y equals 23 take away 3x. And I'm going to start plugging in the x values. So the first x value they gave me was a 2. That means if I want to know what the y value is, I'm going to replace all x's with a 2. There's only one x in this rule. So you could pop that in a calculator and do 23 take away 3 times 2. As long as it's a scientific calculator, it'll do it in the right order and give you the correct answer. Otherwise, make sure you're following the order of operations. You got to multiply or divide before you can add or subtract. So 3 times 2 is 6. And then 23 take away that 6 leaves me with a 17. So then I'd be typing in this box the number 17 in italics. All right, and then the next x value is a 3. Y equals 23 take away 3. Where the x is, I now have a value of 3. That means I'm doing 23 take away 9, and I get 14 from that. So this box will get filled in with the 14. Okay, that's all there is to it. Just finding the y values by plugging in each x value. Any questions on that one? If anybody wants a screenshot, you're welcome to do that, of course. Any old time, you're welcome to do that. So the next thing we're asked to do is identify our dependent and independent variable. I'm just going to label things as a reminder here. And that, again, you're welcome to take a screenshot. But we know the x's are the x is the variable that does not depend on other stuff. We can just choose any value we want for x. And then the y values, well, that's our dependent variable because it depends on what x value I plug in. All right, so when it asks us to identify those down here, I feel like Alex is doing it backwards, maybe just to confuse us. But the first one they ask about is the dependent variable. We have to remember that y is the dependent variable. So the answer here is the test score. It also feels backwards because that's normally the second thing I come up with. If I've got an independent variable, I have to plug that in to find out what the value of the dependent variable is. Oh well, I'll stop complaining. So the number of hours studied is the independent variable in this particular situation. Hi there, is that Deasia? I can't tell me.
Yeah, it's just Deasia.
Good to see you, Deasia. Okay, and then when we have a table like this, it's still the same idea. X variable, think of it as independent, Y is dependent. So in a table, that means the left column is going to normally have your independent variable, and the right column is going to have your dependent variable. It makes sense. How much car costs is very dependent on how old it is. If it's brand new, it's going to cost a whole lot more than if it's really old. So that makes sense. Similarly, on that first one, the test scores definitely depend on how much we study. The more we study, the better our test scores are going to get. So when I go to fill this in, the dependent variable, I'll just put car's price. And the independent variable is the car's age. All right. The last example then is identifying the domain and range when we're given a relation, when we're given a set of ordered pairs. So the big deal that I want to point out is it's asking us to write our answer using set notation. Okay, and remember I said earlier, the set notation is these brackets right here. If you don't use the brackets, then Alex is going to tell you you're wrong, even if every number you put in there is correct. So just be careful with that. Make sure to use the set notation when you're answering these two problems. And so we know that the domain is the x values, or the first numbers in each ordered pair. So when I go to identify the domain, that would be the 1 and the 9 and the 9. I have to use those brackets, but you'll just click that button over there. And then since two of those three numbers are really the same number, I don't have to list them twice when I make a list of the numbers in my domain. Just 1 and 9 is good enough. Then my range is the second number in each ordered pair. So when I go to write my range, I have a 5 and a 3 and a -6. And clearly I did not just write those in numerical order. As a matter of fact, it's exactly backwards. I guess they're numerical order from biggest to smallest, now that I think about it. All right. Any questions? I'll say it one more time because I'm sure that some of us are going to forget when we get here because they're the last two problems. When you get here, click that crazy set brackets notation or you're going to get mad at Alex, okay? Just don't forget to put them in the set notation as you're typing. All right.